Hello guys, in the last video I explained to you how you can set up your Arduino development environment for Windows 11. In this video I'm going to talk about the hardware of Arduino and how it all works, and we are also going to do one small project. There are many Arduino boards which are there all with different components, but all Arduino boards have some common components which are very important. These common very important components are the 5-volt and the 3.3-volt pins, the GND, the WIN, the analog pins, the microcontroller, the digital pins, the USB to serial chip, and the USB port. In this video, I'm going to talk about the functionalities of each of these common components. So first, I'm going to talk about the microcontroller. The microcontroller is the single most important component found in all Arduino boards. The microcontroller is like the heart of the Arduino board. Whenever you write a program saying the Arduino, telling the Arduino board to execute instructions, that program first gets uploaded to the microcontroller. The microcontroller also contains the CPU, the central processing unit, which executes all the instructions written in your code. The microcontroller also contains specific registers which help in UART configuration. UART stands for Universal Asynchronous Receiver Transmitter. UART is a type of communication protocol which sends data one by one from the sensors or the actuators to the microcontroller and from the microcontroller to your computer. Now moving on to the USB to serial chip. What the USB to serial chip does is that whenever you send programs from your computer to the Arduino board, the USB to serial chip converts the code, the instructions in your program to a form which the microcontroller can understand and execute. Similarly, when you send data from the microcontroller to the computer, what the USB to serial chip does is it converts the data from the microcontroller into a form which the computer can interpret. Also, the USB to serial chip allows you to set the baud rate when you send data from your computer to the microcontroller and vice versa. The USB port allows you to connect the USB cable from the microcontroller to the computer, allowing communication to be established between the microcontroller and the computer. And then moving on to the power, the 5-volt and the 3.3-volt pins are there, which provide power, the voltage to external power supplies like sensors, LEDs, actuators. And then there is the GND, which stands for ground, which is negative, which is also used to complete the circuit and connect the components. The WIN stands for voltage in and is also used to supply power to external power components. So now moving on to digital and analog pins. So for communication to happen between electronic components, there have to be electronic signals. There are two types of electronic signals, digital and analog. So first, let's get to know about digital. So digital pins are used to describe the state of electronic components as on or off. Basically, these on or off states can be described as 0 and 1. 0 stands for there's no voltage which is passing through, and 1 stands for there is voltage which is passing through. So suppose I have an LED which is connected to the digital pins. 1 will mean that voltage is being passed through, in other words, the LED is on, and 0 means that no voltage is currently being passed through, so the LED is off. So 0 and 1 are used to describe the state of the LED in this case. So digital pins are used like that. They define the logic of electronic components as on or off. So 0 and 1, where 0 stands for low and 1 stands for high. Now moving on to analog pins. Analog pins work much more differently. Analog pins don't just have two states. They actually quantize values which are received, which are got from the sensor. So let's talk about analog signals in more detail. So suppose I have a temperature sensor connected to a 5-volt analog pin in my Arduino Uno board. What the temperature sensor will do is that based on the temperature of its surroundings, it will give a value between 0 to 5 volt because it's connected to a 5-volt pin. Then that value will go to the ADC, which is the analog to digital converter. And suppose my ADC has a 10-bit resolution. What this means is that my ADC will represent the value from the temperature sensor as 2 to the power 10, as a range of 0 to 2 to the power 10, and 2 to the power 10 is 1024. So the value which is received it will go to the ADC, which will represent it as a range of 0 to 1024. This is how analog signals work for most sensors. Now you guys know how the basic hardware, the basic components of the Arduino board all works. Now we're going to do the project, the Arduino project. And to do that, you have to first open the Arduino development environment like I have. Then go to File. Then you have to click on Examples. Then you will see all these options. Then go to Basics and then click on Blink. So then it will open another Arduino IDE tab with the preloaded pre-installed code over here, and then it explains you the code. So the purpose of this code is that it will turn on the LED for 1 second and then off for 1 second, and this will happen repeatedly. So now what we are going to do is I'm going to explain this whole code to you guys, and then I'm going to connect my Arduino board to this to see whether it works. So now you see the setup function over here. So this setup function means that whatever you write under that function, that code will only be run once. Typically, the code which is under this function is basically lines of code which initializes the connections in your Arduino board, initializes the values of variables, sets up the baud rate, etc. And then you see this loop function over here. The code which you write under this is typically the hard code which needs to be executed, like the main code, and this keeps running. This code which you write under this loop function, this keeps running in the loop. So if you see in most Arduino sketches, in all Arduino sketches, there'll be a setup function and there'll be a loop function. So this is the default structure of a code. Then first you have to write code under the setup function, which will run once, and then under the loop function, the code which will execute and run in a loop. So this is the basic structure of all Arduino sketches which you will write. Now to explain the actual functions in the code, the first function we'll be looking at is the pin mode function right under the setup function. So what the pin mode function does is it takes two parameters. One is the digital pin number, and one is the mode which you would like it to be. So if you go to pin mode, you will see the parameters which it takes over here. So one is the pin and the second is the mode. Okay, and when you click an LED built in, you will be thinking that why isn't the pin number written over here in the first parameter? Actually, a variable is written which represents a digital pin number, so don't get confused by this. So basically LED built in, it's a built-in LED inside the Arduino board which is under the digital pin 13. So the pin number is written as the first parameter, and the mode we want it to be is output. What our output mode means is that we want to send instructions to the built-in LED for it to execute. Now for the second function under the loop one, it's called digital write. Digital write also takes two functions. The first function is the pin, and the second function is the state that we want the pin to be in, high or low. So the LED built-in is the first pin, which is represents pin number 13. So LED built-in represents pin number 13, which is the first parameter, and we want the built-in LED to be in high state. I explained before in this video that high state means that current is passing through. That means that the LED is on. As it is connected to a digital pin, it only has two states, high and low, and high means that the LED is on as voltage is passing through. Now for the delay function, the delay comes after digital, right? Delay 1000. So what this means is that turn the LED on for 1 second. So what this does is it pauses all the other programs running in the Arduino IDE and executes the function in the previous line. So it'll keep the LED on, and the rest of the functions which it was executing before, it will stop that, and it will turn the LED on for 1 second. 1000 over here, 1000 refers to 1000 milliseconds, which is 1 second. Then we encounter the digital write function again. So again, two parameters. LED built-in refers to the pin number 13. We want it to be in low state now. Now guys, low state means that the LED is off because voltage is not passing through, and we want this to happen for 1 second. And this will keep repeating as all of this is written under the loop function. So this is all the basic functions which are written in this code. Now I will test out this code to see whether it works in my Arduino board. So now I've connected my Arduino board to the computer using the USB cable. It's connected for sure because it's written Arduino over here, as you can see in my computer. And there's also a green light, which is the confirmation over here. The green light which you see over here, this confirms that my Arduino board is connected. Now my Arduino board is connected, but I also have to make sure that the correct board is connected, which I can check from here. So yes, over here it's confirmed that the correct board Arduino Uno is connected. And then you also have to confirm that the correct port is connected. So you have to go to Tools, Port, and then you see that the correct port is connected. So I'm just double checking the COM5 port. Yeah, that is the correct port which is connected. Now I'm going to upload my code, but before uploading my code, I'm going to verify it to check for errors. So you can see what processes are being done over here. It's written done compiling, and then it shows that it uses 2% of program memory space and all those statistics. Then it's no errors are shown over here, otherwise it would come in this output black screen over here. And then as no errors are there, I'm ready to upload, so I click on upload, and then compiling sketch, done uploading, and it's saying done uploading, and that means my code has been uploaded. Now let's see if it works. Now as we have uploaded our code, let's see if it's working. So you see this LED over here, this light over here. Our goal was to make this LED, this built-in LED, blink for 1 second and then turn off for 1 second. And as you can see, that's what's happening here. So that means our code is working. Congrats, you have just finished your first Arduino project. Now if you want, you can play around with this code a little bit. So I just changed 1 second to 5 seconds in both these lines of code. So now my code should the LED should be on for 5 seconds and then be off for 5 seconds. So let's see if this works by verifying it first and then uploading it. So we verified it, no errors, that's good. Now we are uploading it. Let's see if it works. So uploading is done. So let's see whether it works. So as you uploaded a new code for 5 seconds, let's see whether it works. So it's on, and it's off. Let's see if it'll again turn on after 5 seconds. And it does. So our code is working. Congrats. I hope everybody enjoyed this video. If you enjoyed it, please give us a like and subscribe, and please share the video. Thank you.